Hey DevOps enthusiasts! Today, we're building a CI/CD pipeline from scratch using Azure DevOps and Azure Repos. Stick around because I have a surprise challenge for you at the end. Ready? Let's go! Before we dive in, what do you think CI/CD stands for? Drop your answer in the comments. CI stands for Continuous Integration, which means every change in code is automatically tested and merged. CD can be continuous delivery, ready for release, or continuous deployment, automatically deployed to production. Imagine working on a huge project with a team. Without CI/CD, merging code would be a nightmare. But with automation, it's seamless. Cool, right? Think of CI/CD like a pizza delivery system. Imagine a pizza shop where multiple chefs are preparing ingredients. Before any pizza gets delivered to customers, it needs to go through a quality check to ensure it's cooked perfectly. CI, continuous integration, is like ensuring all ingredients are fresh and correctly assembled before the pizza goes into the oven. Every time a chef adds something, it's checked to avoid mistakes. CD, continuous delivery deployment, is like having a system that ensures the pizza is either ready for pickup, continuous delivery, or automatically sent out for delivery as soon as it's done, continuous deployment. Just like a well-run pizza shop, CI/CD helps software teams deliver high-quality applications quickly and efficiently. Let me give you another real-time example. Think about a popular app like Instagram. Developers constantly push new features, like Reels, stickers, or UI tweaks. Without CI/CD, they would have to manually test every single change, which would slow down releases. With CI, whenever a developer submits new code, for example, a new filter for Instagram stories, automated tests ensure it doesn't break existing features before merging into the main branch. With CD, Instagram engineers can choose to either have the update ready for manual approval, continuous delivery, or release it instantly to users, continuous deployment. That's how we get frequent updates without bugs ruining the app experience. Let's get hands-on. We'll use Azure DevOps Pipelines and Azure Repos and Git Bash. Which other tools do you use? Comment below. First step is version control in Azure Repos. First, push your code to an Azure repo. If you haven't done this before, type Azure Repo in the comments and I'll make a tutorial. I have this ASP.NET Core API project. I'm using Git as a version control. Let me create two branch QA and staging for our CI and CD pipeline. You can see all branch has been added to the repo in Azure DevOps. Now we are going to deploy this API to the target server using CI/CD pipeline. Step 2 is CI, automated build and test in Azure Pipelines. Now let's set up a classic pipeline in Azure DevOps. On the left-hand side panel, select Pipeline. Click on a new pipeline. It is asking, where is your code? That means, which version control tool did you use to push your code, or where your code is pushed. This is all YAML formatted. For now, I will show you how we can create pipeline using Classic Editor, which is easier than YAML. So select Classic Editor link, which is in blue color. Now here you will have to select Source. I am going to select Azure Repos Git, because I have used Azure Repo to push my code. Team Project is selected already because we are creating pipeline in this project. Then you can select repository and branch which you want to build and release. You can choose different branch at the time of trigger as well. Then hit Continue. Now it's time to select template, which default template having all pre-made tasks. If you will select empty job, you will have to manually select task and add it. I will select ASP.NET Core template because my project's framework is ASP.NET Core. You can add or remove task as per requirement. So basically my project is using ASP.NET Core with .NET 8.0 SDK. So now let's try to understand each and every job and task of the build pipeline. Give it a meaningful name of the build pipeline. Next is agent pool. To build your code or deploy your software using Azure Pipelines, you need at least one agent. As your code base and team grow, you need more agents. When your pipeline runs, the system begins one or more jobs. An agent is computing infrastructure with installed agent software that runs one job at a time. Azure Pipelines provides several different types of agents. For example, one of them is Microsoft-hosted agent, where agents hosted and managed by Microsoft. Second is self-hosted agents, agents that you configure and manage hosted on your VMs. I don't have my hosted VMs, so I will use Microsoft-hosted agent Azure Pipelines. Then next is agent specification, which defines the type of machine that will execute the tasks within a pipeline job, whether it's a Microsoft-hosted agent or a self-hosted agent. I will select Windows 2019, which is required for my project. Then next is parameters. That you can specify in the relevant tasks as well later on. But if you will specify project file which is going to build, which should be the path of CSP-ROJ file or solution file, then you don't need to specify it in the next task, because you will need to add this values in maybe 2 or 3 tasks. But I will unlink all parameters since my project doesn't has unit tests. Then moving further, next is get sources. No need to make any changes here. Moving on, agent job is a grouping of the tasks. You can add task by selecting plus. Here, the one thing is important is demands. You can set your custom demands. For example, if you want to run this pipeline on particular agent machine, then add demands as agent.name equals server name. Then this pipeline must run on that server only. Similar way, there are lots of demands you can set. I put link in the description box, you can refer it for more demands. Those are all the tasks under job. So I can say we have one agent job which has multiple tasks. Now, as I mentioned before, my project is using .NET 8.0 framework, so I have to install it. This is prerequisite of my project. So I will add task. Click on plus and select Use .NET Core Task and click Add. Now move this task at first position, because first step is installation. Now select the package to install. Select SDK contains runtime, which is required for my API. Give version number as which version of SDK you need. Next task is restore, which is using the .NET restore command to download and manage NuGet packages that your .NET Core project dependencies require, ensuring they are available for building and running the application. Give the path of your project here. Select feeds and authentication. I'm using NuGet.org, so I selected that. If you have your own library, you can select that. I have already created video for how to create artifacts feed. Next task is build, which will actually build your project. Give CSPROJ or SLN file location. I am going to disable test task because my project doesn't have test cases involved. Next task is publish. I'm going to disable this publish task. I'm going to use index sources and publish symbols because it uses if you need debugging support and symbol mapping for crash analysis. Use .NET Core Publish if you want to package and deploy your application. Next step is copy files, which is not required. This is useful to copy files from source folder, where all files required to run website to artifacts directory. By copying only the necessary files, we avoid sending unnecessary dependencies or temporary files to the deployment target. This improves deployment speed and reduces storage usage. Last step is publish artifacts. Use this task in a build pipeline to publish build artifacts to Azure Pipelines, TFS, or a file share. In the Path to Publish task, specifies the folder or file path to publish. This can be a fully qualified path or a path relative to the root of the repository. Wildcards are not supported. In the Artifact name specifies the name of the artifact to create in the publish location. Now we all done configuring build pipeline. Click on Save and Queue. You can see it is providing us an option to choose branch. Click on Create. It will start build our project. You can see all the steps are running smoothly in the Microsoft-hosted agent. Once build is done, you can see artifacts has been saved to the drop folder, which are files that are going to deploy to the server. Now let's move on to the release pipeline. From the left-hand side panel, click on Releases under Pipelines. Click on New and hit Create New Pipeline. Again, similar as Build Pipeline, we can select Predefined Template or select Empty Job. My website is going to deploy to IIS, so I'm going to choose IIS Website Deployment Template. Hit Apply. Give relevant stage name. Stage owner would be your name as you're creating pipeline. Now we have to link artifacts that we created using Build Pipeline. Click on Add an Artifact. You can choose source type as Build because our artifacts are coming from Build Pipeline. In some case, we don't need to build application. Then you can choose Azure Repos or GitHub or TFVC. Select a build pipeline name that you have created to link artifacts. You can select version. I would suggest to select latest. That means it will always deploy latest build to the target server. When you go to the build pipeline, check You Build Runs. You will see version number. Now click on One Job, Two Tasks blue link. In the first task, give name of the stage. Then since we selected IIS Website Template, therefore it is selected as IIS Website in configuration type. Action that we are going to perform, create or update website. Next is give a website name that you want to create. I would uncheck binding because in the corporate world, developers usually create website with app pool and binding, so you don't need to add binding here. Next is IIS Deployment Job, where you have to select deployment group along with the tag on which server you want to deploy your website. I have already uploaded separate video deployment group. Please check it out. Then under the job, we have first task is IIS Web App Manage. This task is about to create website or application or directory and app pools. Configuration type, action, and website name is already defined since we added details in the previous step. Give a physical path of the website where you will store files required to run website in the target machine. As I mentioned before, we are not going to create app pool through the pipeline, so don't select it. Next step is IIS Web App Deploy. This task will deploy your application using Web Deploy. In this task, you just need to select package or folder of your application that we got from Build Pipeline. Basically, artifacts. Give name to the pipeline. And save it. We are done. Go back to Pipeline tab. Click on the Flash button on Artifacts, where you can enable Auto Trigger. Give the branch filter. If branch name contains QA, then it will trigger. Close it. Now click on Flash button on stage. Here also you can set filters. For example, you only want to trigger this stage when branch name contains QA. So here, let's say we have modified QA branch, then it is satisfying artifacts condition, because we set filter for QA branch so it will trigger, and also this stage is set for QA branch, so this stage will trigger. You can also set approval, means if someone will approve your deployment, then only it will start running. Click on Men symbol. Click on Pre-Deployment Conditions and add approver's name. So when this person will approve it, pipeline will start running. Now let's create another stage as staging environment. Just hover on QA stage and click on Clone. It will create clone of the QA stage, make some changes. Click on Flash button of the staging and select After Release as Trigger, because I want to release this stage after QA is done. Similar way, set filter for staging branch, that this stage will only run if branch name contains staging. Give stage name as staging. Make new website for staging stage on the server. I already have website created on my server. Now make some changes accordingly to the pipeline stage. I am removing approver for this stage and save it. Now click on Create Release. Here, if you have multiple stages, you can select it. Right now I'm selecting staging stage only. Let's see. Also, you can select version of build. Hit Create. You will see new release has been created. Go to that release. You can see that QA is not deployed because we selected only staging stage. And in the staging stage it says artifacts condition not met. That's because we set filter for staging branch, and we selected version of master branch build. So let's build QA and staging branch. Okay, build for QA is done. Let's run release for QA stage. See, it is asking to approve it. Let's approve it. It has started running pipeline. Click on the logs. You will all task running here. Now let's try staging stage using staging branch build. Confirm the version number and create it. It starts running because filter we set for staging branch only, and we are deploying stage branch. Let's check the logs. Yes, it is running. Let's wait for a few seconds. And done. CICD isn't just about deploying, it's about monitoring too. Tools like Azure Monitor Application Insights and Log Analytics help track performance. Do you use monitoring tools? Yes or no? Here's the challenge. Set up a simple CI/CD pipeline in Azure DevOps and share a screenshot in the comments. If this helped, smash that like button and subscribe for more DevOps magic. See you in the next one.